All right, so this is some homework review. I had a question about MathXL 6.5, numbers 11 and 12. So we're going to go through both of those problems real quick for you. All right, so here's number 11. Two radicals, both equal to 0. This is a little bit easier than the next one. We're going to do two radicals equal to a number. Okay, so basically the idea when we're solving radical equations is that you want to isolate the radical and then square roots, right? So isolate the square root and then square both sides to make them go away. Sometimes you'll get them all in one shot, like here. In the next problem, we're going to have to do this We're going to have to do these steps twice. Okay, so the first thing I want to do is get one of the radicals by itself on the left-hand side or the right-hand side, doesn't matter. As long as it's one radical on one side, and then let's see what's left over on the other. So we're going to just add this radical to both sides to move it over. Okay, so I have the square root of 7y plus 2 is equal to the square root of 6y plus 7. Now this is great because now when I square both sides, these are both monomials, right? There's one thing on each side of this equation, right? Just the radical. So when I square a radical, when I square a square root, it just goes away. And we have 6y plus 7. Now I have a very simple and straightforward linear equation. Subtract 6y from both sides, gives me y. Subtract 2 from both sides, and it gives me y is equal to 5. You definitely want to check your answer for these problems because we could have extraneous solutions. So 7 times 5 is 35 plus 2, that's the square root of 37. Weird. You might think you could have made a mistake, but it's okay because 6 times 5 is 30 plus 7, so it's the square root of 37 minus the square root of 37. Even though they don't work, even though they're irrational, right, they both still subtract to give you 0. So there's my answer. In this case 5, but here's the steps, right? Move one of the radicals to the right-hand side, square both sides. This one is slightly more complicated because now my goal is still the same, is to get one of the radicals by itself. So I'm going to add this, and I chose this one and this one in this case because they're negative, and by moving them over to the right-hand side, it makes it positive. So I have the square root of 4y plus 29, and that's equal to 6 plus, you can't add these together. So now when I square both sides, this is a monomial. So it just turns into 4y plus 29. But when I square the right-hand side, I now have two terms. I have the 6 and I have this thing. And remember that when we square a binomial, you always get a middle term. Okay? So we can't just say it's 36 plus y minus 4. That's not going to be it. It's 36 plus 12 times the square root of y minus 4 plus y minus 4. A squared, 2 times a times b, b squared. Okay. So now, got another radical. Okay. So now I have to isolate that radical and then square both sides again to get rid of it. Well, let's just subtract y from both sides. That gives me 3y. Let's subtract 36 from both sides. And let's add 4 to both sides. And so that turns into a minus 3 is equal to 12 times the square root of y minus 4. Now, I could, if I wanted to, square both sides like this, but I want to make this problem a little bit easier, so I want to divide out any common factors from both sides, and we can divide everything by 3. I could divide everything by 12, but then I'm going to get fractions over here on the left, and that's going to actually make this question harder. So that's y minus 1 is equal to 4 times y minus 4. Square both sides again to get rid of this radical. And don't forget the middle term, y squared minus 2y plus 1. 16 times, now the square root goes away. Now I distribute the 16. And setting this equal to 0, if this is still y squared minus 2y plus 1, I'm going to subtract 16y from both sides. I'm going to add 64 to both sides, and I get y squared minus 18y plus 65 is equal to 0. This does factor into two numbers that multiply together to 65, add up to 18, and that is 5 and 13. So x is equal to, or y is equal to 5, and y is equal to 13. Now, before we say both of those are my answers, you have to go back and you have to plug them in to see if it works. So let's just remind it, it's 5 and 13. So 4 times 5 is 20, plus 29 is the square root of 49, which is 7, minus 5 minus 4 is 1, square root of 1 is 1, 7 minus 1 is 6. Boom, that works. Okay, next, let's try 13. 4 times 13 is 52, plus 29 is 81, square root of that is 9. Second part, 13 minus 4 is 9. So that's minus square root of 9 minus 3, which is 6. Boom, they both work. Okay, so that was MathXL 6-5 homework, questions 11 and 12.